Hello, everybody. In today's lesson, Module 16, Lesson 4, we'll be talking about dot plots and data distribution. And basically, our essential question that we should be able to answer at the end of our lesson is, how can you summarize and display numeric data? Okay, so let's look at the Explore activity on page 471. So the question, how does a typical cat weigh, is an example of a statistical question. A statistical question is a question that has many different or variable answers. All right, so in the 1 through 5, we're going to decide whether each of these situations is a variable situation or a statistical question. So your sister wants to know the typical weight for an adult cat. Yeah, that would be variable. Not every cat's going to weigh the same. You want to know how tall your friend is. Okay, well, that's only one person, right? So there's no way for it to vary. So that's not variable. You want to know how far your house is from school. Again, because they're only asking one person, it's not variable. If you collected data on several students or several people, then yes, that would be a statistical question. But since it's only one piece of information, not variable. A car owner wants to know how much money people usually pay for a new tire. How much money people usually pay for a new tire. That is variable. Okay, number 5. How many students were in line for lunch at the cafeteria today at 12:30? Okay, there's no way, it's only one day and one time period, so it's not variable. If you collected information about the whole week, it would be variable. All right, B. For which questions, or for which of the situations in part A, can you write a statistical question? Write questions for these situations. Well, numbers 1 and 4. And the question, how much does a typical cat weigh? And how much does a tire usually cost? Okay, so those would be statistical questions based on numbers 1 and 4 in our information. All right, choose one of the questions you wrote in part B. And how might you find answers to this question? What units would you use for the answers? Well, let's look at the how much does a typical cat weigh? How would we get that information? Well, we'd have to get the weight of various amount of adult cats. And record their weights. I suppose we could use pounds or kilograms to record the information. Right? Page 472, making a dot plot. So statistical questions are answered by collecting and analyzing data. One way to understand a set of data is to make a visual display. A dot plot is a visual display in which each piece of data is represented by a dot above a number line. It's basically very similar to what you learned in previous grades as a line plot, where you put X's above each of the numbers to represent the frequency of the data. Okay, so let's look at this one. A baseball team manager records the number of runs scored by the team in each game for several weeks. Use the data to make a dot plot. So we have all these numbers here, and then they put dots above each one as they went along. Okay, So you make a number line so they would include all the pieces of data. So it goes from 0 to 11. And we're collecting runs scored. And these are the times or the number of times the team scored that many runs. So now, how many games did the team play during the season? And how can you tell from looking at the dot plot? Well, if we count the the dots on the plot, that tells us how many games. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Okay. Just count the dots. All right, now how many games did the team score 2 runs or fewer? And how do you know? 2 runs or fewer. Okay, so we're going to add up the 2s, 1s, and 0s because that would be 2 or less. So 2, 4, 6, 9, 10. How do we know there are 10 dots above 0, 1, and 2? Okay, so 10 games. We just counted the dots for 2, 1, and 0. And how do we know? Because it had 10 dots. All right, so number 4. A different baseball team scores the following runs in its games for several weeks. Okay, use the data to make a dot plot and tell how many games the team played. So let's put these in order. So we have 1 would be our lowest number, 2, and we're going up as high as 6. Okay, so we don't need to really spread it out any further than that. 1, there are 2 games where they scored 1 run. 1, 2, 3 games where they scored 2. 2 games scoring 3 runs. 4 games scoring 4. 2 games scoring 5. And 1 game scoring 6. All right, so tell how many games the team played. So there's 2, 4, 6, 8, 10, 12, 14 games. The team scored 4 runs the most times. Okay. Okay, let's look at number 5. Page 473. So how do we interpret a dot plot? So a dot plot can give you a visual picture of the spread, center, and shape of data distribution. So spread, we know, is how far the numbers are spread apart. The center, it would be like the mean or the median. The shape would be looking at, is the data like symmetrical? So you can describe the spread of data by identifying the least and greatest values. We know that as the range. You can also look for outliers, which are data values that are either much greater or much less than the other data values. Let's say we have a bunch of information that's 2 through 5, and then there's one number that's 13. Well, 13 is a lot different than 5, right? It's much further away, so we call that an outlier. And so we can describe the center and shape of a data set in terms of peaks, clusters, or symmetry. So a symmetric distribution has approximately the same number of data values on either side of the center. All right, so let's look at example 2. So A, the data values are spread out from 3 to 7 with no outliers. Okay, so everything's kind of grouped together here from 3 to 7. If let's say there was a number way over here at 13, we would call that an outlier. Okay. The data has a cluster from 3 to 7 with a peak at 5, peak being a high point, right? The distribution is symmetric. Okay. They're basically balanced on both sides. Which means that the data values are clustered around the center of distribution. Okay, here would be the center, and then we have equal amounts on either side of it, or close to equal amounts on either side. All right, now B, these numbers are spread out from 1 to 9, but most of the numbers are from 6 to 9. So this number way over here, 1, that's an outlier. It doesn't appear to be typical of the data. And so it has a cluster from 6 to 9, and it has its peak at 9. And it's not symmetric, right? Okay. It's not equal amounts on either side of the center. All right, so 5. Describe the spread, center, and shape of the data distribution from example 1. So let's go back to example 1. Okay, and so we had this right here, and we have an outlier over here, right, with 11 runs. So we have a cluster from basically 0 to 7, and its peak at 2. Okay, so the spread's from 0 to 11 on example 1. I would say 11 is an outlier. Okay, again, because most of the runs are not greater than 7. Okay. The data clusters or groups together from 0 to 7 with a peak at 2 runs. And it was not symmetrical. The data is not symmetric. Okay, again, if it was symmetric, we might have like this 2 here, and then it would have equal amounts on both sides. But there are more numbers to the right of 2 than there are to the left. All right, 474. Finding measures from a dot plot. We can also find and calculate measures of center and spread from a dot plot. All right, so the dot plot on example 3 shows the number of runs scored by a baseball team in each game for several weeks from example 1. So to find the mean, median, and range of the data. Step 1, to find the mean, find the sum of the data values. So basically we're just adding all these up, right? There's one set that were 0, so 1 times 0. There were 3 that were 1, so 3 times 1. There were 6 that were 2, and so on, okay? So the total of these data points is 61. There were 19 data points, so it's approximately 3.2. Step 2, the median. We're going to count the dots from left to right until you find the middle value. You may need to find the mean of 2 middle values, and in this case, the median is 2. So if we cross off from the ends, we're left with just 1 in the middle, 2. And to find the range, we find the largest value, the smallest value, and subtract. And our range is 11. So B, how many runs does a team typically score in a game? Well, on this case, we're going to be looking at the mean and the median, right? And so the mean was 3.2. the median was 2. The shape of the dot suggests that the outlier 11 may have affected the measures of center, right? It increased the average or increased the mean. So in that case, I would use the median. Or in this case, they're saying, let's find the mean without the outlier. So in this case, if we subtract the 11, we'd have 50 divided by 18, which is approximately 2.8. So without the outlier, the mean is 2.8, which is less than the original mean, right? So now if we find the median without the outlier, we would still have two twos in the middle. So we still have a median of 2. So given the fact that if I took out the outlier and the median still stayed 2, 2 is probably more typical of the data. Okay. All right, 475, number 6. Find the mean, median, and range of the data from your turn question 4. What is the typical number of runs the team scores in a game, and justify your answer? Okay, so set 4. So we have 1 run times 2. Okay, because there's 2 situations where they scored 1 run. 2 times 3. 3 times 2. 4 times 4. 5 times 2, and 6 times 1. So what does that give us? That gives us 2, right? 2 times 1 is 2. 2 times 3 is 6. 3 times 2 is 6. 4 times 4 is 16. 5 times 2 is 10. And 6 times 1 is 6. Add those up. We have 3 6s. That's 18, 20, 30, 46. 46 divided by 14. Okay, what is 46 divided by 14? It's about 3. So basically, approximately 3.28. I would say the mean is about 3.3. So the mean's about 3.3. The median, we can just look at our example on 4, take off from the ends and work our way towards the middle. So I'm going to take one from here, one from here. I'm going to take this one and this one, this one and this one, this one, this one, this one. I'm sorry. Okay, I'm going to circle them so we can see them. Okay, so I've eliminated the 2 extremes there. The next 2 would be there. This one and this one. This one and that. This one and that one. This one and this. And so we're left with 3 and 4. So our median's 3.5. And the range is 6 minus 1, or 5. All right, tell whether the situation could yield variable data. If possible, write a statistical question. All right, the town council members want to know how much recyclable trash a typical household in town generates each week. Yeah, that would be variable, right? My family might throw away less trash or more trash than your family. So the question could be, how many pounds of recyclable trash does a typical family generate, or a typical household? All right, how about number 2? Kate asked some friends how many movies they saw last winter. Use your data for numbers 2 and 3. Make a dot plot for the data. So 0, okay, I see that there's one person that didn't see any. 2 people saw 1 movie. 2 people saw 2 movies. 3 people saw 3 movies. 4 people saw 4 movies. 4 people saw 5 movies. 2 people saw 6. 3 people saw 7. 2 people saw 8. 2 people saw 9. And 1 person saw 17. Okay, so you see all the data is clustered way over here from 0 to 9, and 17 is off by itself. So it appears that 17 is an outlier, right? So find the mean, median, and range of the data. So the mean. So we could probably just add these up. They're smaller numbers. So 1 and 1's 2, 4, 6, 9, 12, 15, 19, 23, 27, 31, 41, 51, 57, 63, 70, 77, 84, 92, 100, 109, 118, 135. So 135 divide by 2, 4, well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, 26. So 135 divided by 26. All right, so if we round to the nearest tenth, it'll be about 5.2. The median, so we can cross off from the ends. And oh, 17 so far over, I forgot to do 17. So let's do this. Cross off from the ends. All right, and so we have 2 5s left in the middle, so the median is 5. And the range is 17 minus 0, so 17. All right, 4. Describe the spread, center, and shape of the data. All right, so the spread is from 0 to 17. "17" appears to be an outlier. The data clusters from 0 to 9 with a peak at 4 and 5. Okay, is the data symmetrical? Okay, so if 4 and 5 is the center, no, it's slightly more to the right, so I would say not symmetric. Okay, when I say they're slightly more to the right, there's 10 numbers to the right of 4 and 5, and there's 8 numbers to the left. All right, number 5. What are some measures of center and spread that you can find from a dot plot? Well, it's the ones we've been working on. We can find the mean, we can find the median, we can find the range. Okay. And how can making a dot plot help you visualize a data distribution? Well, we can see if it's symmetrical, right? We can also see clusters. Okay, so we can also see clusters and peaks using a data plot. 476. Describe how a statistical question yields an answer with variability. Give an example. All right, so remember like when we were talking about wanting to know how tall a friend is? That wasn't variable because only one person's information was to be gathered. So a statistical question would involve data that varies. So basically, so what is a question that we can come up with that would be statistical? Well, not everybody has the same foot size. So what is the typical shoe size of a sixth grade boy? All right, 7 through 10. Determine whether the question is a statistical question. If it is a statistical question, identify the units. All right, an antique collector wants to know the age of a particular chair in a shop. Particular chair. So that's only one chair, not variable. So not statistical. How tall do the people in your immediate and extended family tend to be? Well, that would vary, right? So that's statistical. And basically feet and inches. 9, how tall is Sam? No, that's only one person, so not statistical. 10, how much did your classmates typically spend on music downloads last year? That would change, right? Some people didn't spend any, some spent a lot, so on. So, and our measurement probably is dollars. 11. For 11 through 14, use the following data, and the data give the number of days of precipitation per month during one year in a city. So the title of our data plot is number of days of precipitation. Okay, I'm going to go ahead and put the numbers in order first. So our least amount is 9. And we have 1, 2, 3, 4 days of 9. And we have 1, 2, 3 days of 10. We have 1 day of 11. We have 2 days of 12. And they have 1, 7, and 8. All right, so 2, 4, 6, 8, 10, 12 pieces. 2, 4, 6, 8, 10, 12. All right. All right, how many days of 7? 1. How many days of 8? 1. There were 4 months with 9 days of rain. There were 3 months with 10 days of rain. There was 1 month with 11 days, and then there was 2 months with 12 days of rain. So our data clusters from 7 to 12. There doesn't appear to be any outliers. Right? So each dot represents number of months with that number of days of rain. And how many months are represented? 2, 4, 6, 8, 10, 12. 12 months. Describe the shape, center, and spread of the data. Are there any outliers? There aren't any outliers. Okay, so the spread is 7 to 12. The data clusters from 7 to 12 with a peak at 9 days in a month. The data is not symmetric. Find the mean, median, and range of the data. So we have 7 times 1. There's one month of 7 days. There's 1 month of 8 days. There's 4 months of 9 days of rain. There's 3 months of 10 days of rain. There's 1 month of 11 days, and there's 2 days with 12. Okay, so 7 plus 8 plus 36 plus 30 plus 11 plus 24. So how did I get those numbers? I just multiply. 7 times 1, 8 times 1, 9 times 4, 10 times 3, 11 times 1, 12 times 2. Okay, 7, 8 is 15. 15 and 36 is 51. Plus 30 is 81. Plus 11 is 92. Plus 24 is 116. So 116 divided by 12. So we have 9.66, so the mean is about 9.7. The median. Okay, so again, we put the numbers already in order, so we can cross off from the ends until we find the middle value. So I have 9 and 10 in the middle, so that's going to be 9.5. And the range is going to be 12 take away 7, so 5. All right, so during 1 month, what if during 1 month there were 7 days of precipitation? What if there had only been 3 days of precipitation that month? How would that change the measures of center? Well, 7 was already our least amount, right? So if I took away the 7 and put it 3, I'd probably have an outlier now. The 3 would probably be an outlier, but it's not going to change the median. The mean might go down a little. Okay, so and the range would also decrease. So let's see. The mean, we'd be subtracting 4, so we'd have 112. No, I'm so sorry. Yeah, I'm subtracting 4 because we went from 7 to 3, so that's a difference of 4. So now we're at 112. And we have 9.33, so the mean would change from 9.7 to 9.3. The median would stay the same. And the range would increase from 5 to 9. All right, 16 through 20. Use a dot plot of the number of cars sold at a car dealership per week during the first half of the year. Okay, so we have to find the mean, median, and range. Well, the range is the easiest. Each of these lines is worth 2, right? 2, 4, 6, 8, 10, 12, so on. So the range is 22 minus. So we notice that this line is 6, and these are in between, so that's got to be 5. So 22 minus 5, so the range is 17. The median. If we cross off from the ends and work our way towards the middle, we'll find the median. Okay, well, all the numbers left are in the middle. Are at 10, so 10 is the median. And the mean. So we have 5 times 2, 6 times 2, 7 times 1, 8 times 3, 9 times 2, 10 times 5, 11 times 1, 12 times 3, 13 times 2, 15 times 2, plus 22. Okay, so let's simplify these numbers. So 10, 12, 7, 24, 18, 50, 11, 36, 26, 30, 22. All right, so 22, 29, 53, 71, 121, 132, 168, 194, 224, 246. And we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 pieces of data. So we have a mean of about 10.2. So it'd actually be 10.25 for the mean. All right, so the mean 10 and 1/4, the median's 10, and the range is 17. So now 17. The owner of the car dealership decides to treat the value 22 as an outlier. Which measure of center or spread is affected the most if the owner removes this outlier? The median is not going to change. It'll still stay 10. If you take out 22, the mean is probably going to decrease the most. So, and also the range would decrease from 17 to 11. No, I'm sorry, 15 and 5, so 10. It would decrease to 10. So the range would decrease from 17 to 10 because it would be 15 minus 5. And the mean changes. Let's see. So if we took away, we had 246. If we take away 22, we'd have a total of 224. If we took that number away, we wouldn't have 24 pieces of data. We'd have 3. So the mean would decrease to 9.7 from 10.2. So the range actually was the most affected. 18. How many cars are sold in a typical week at the dealership? So in that case, we want to look at the median and the mean, right? We see that the mean was 10 and 25 hundredths, or without the outlier, 9.7, and the median was 10. So it's reasonable to say that the typical number of cars sold is 10. Okay, 19. Write an expression that represents the total number of cars sold during the first half of the year. Okay. So that's basically how we solved the problem. So we went 5 times 2 plus 6 times 2 plus 7 times 1 plus 8 times 3 plus 9 times 2 plus 10 times 5 plus 11 times 1 plus 12 times 3 plus 13 times 2 plus 15 times 2 plus 22. Okay. 20. Describe the spread, center, and shape of the data distribution. All right, so the spread is from 22 is from 5 to 22. The number 22 is an outlier. The data clusters from 5 to 15 cars sold. With a peak at 10 cars sold per week. And the data is not symmetric. So the spread is from 5 to 22. The number 22 is an outlier. The data clusters from 5 to 15. And there's a peak at 10 cars sold. All right, 21. Explain how you can tell the frequency of the data value by looking at a dot plot. Oh, we just have to count. Right? If I wanted to find out how many were 15, I just count the dots. All right, 22 through 26 use the following data. The data give the number of runs scored by opponents of the Boston Red Sox in June of 2010. All right, I'm going to go ahead and put these in order from 0 to it looks like 11. 1, 2, 3, 4, 5. So there's 19 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so how come I only have 18 here? 2 zeros, 1, 1, 1, 2, 3, 4, 5 twos, 1, 2, 5 twos, 1, 3, 4 fours, 2 fives. Oh, I left off 9. Okay, so now we have the information right. So 0. Put 2 dots above 0. Put 1 dot above 1. 5 dots above 2. 1 dot above 3. 4 dots above 4. 2 dots above 5. 1 dot above 6. 1 dot above 8. 1 dot above 9. And 1 dot above 11. All right, so how many games did the Boston Red Sox play in June 2010? Just count the dots. 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 games. All right, 24. Which data value in your dot plot has the greatest frequency? 2. Their opponents score 2 runs in the most games. Find the mean, median, and range of the data. Okay, the range is 11 minus 0. So there's a range of 11. The median, cross off from the ends until we find the middle value. Four. And the mean. Well, we can add these up. Fairly simple. So those are zeros. So 1, 3, 5, 7, 9, 11, 14, 18, 22, 26, 30, 40, 46, 54. Oh, yeah, sorry. Lost my place. 11, 20, 28, 34, 44, 48, 52, 56, 60, 63, 65, 67, 69, 71, 73, 74. So 74 divided by 19. So about 3.9 for the mean. All right, and 26, what is a statistical question that you could answer using the dot plot? All right, so if our question was, what was the typical number of runs scored against the Red Sox in June of 2010? We know the mean is about 3.9. The median was about 4. So that means there were about 4 runs per game scored against the Red Sox. All right, 27. A pediatrician records the ages of the parents of the patients seen in one day 1, 2, 5, 7, 9, 17, 13, 16, 18, so on. Assuming that some of the patients are infants who are less than 1 year old, what information did the pediatrician forget to write down? Well, months, right? So units for ages. So in other words, is this 2 months or 2 years? Is this 16 months or 16 years old? Could be 16 weeks old. So we need to know that information. Can you make a dot plot of the pediatrician's data? No, because we have to measure. To make a dot plot, we have to use the same type of information. So no. So another way to use a dot plot is to have the same units for each patient. All right, and 28. A nurse measured a patient's heart rate at different times over several days. Okay, so heart rate. Let's quickly put these in order from least to greatest. It looks like 82 is the smallest, then 83, 84, 85, 85, two 85s, 86, 1, 2, 3 days of 86, 87, 1. Actually, there was 4 days of 86, 87, 2 days, 88, 89, 90. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 days. 2, 4, 6, 8, 10, 12, 14. All right. And so our range is going to be from 82 to 90. 82, 83, 84, 85, 86, 87, 88, 89, 90. So let's see. We go 80, 81, 82. Okay. All right. How many days of 80? 0. 81, 0. 82, 1 day. 83, 1 day. 84, 1 day. 85, 2 days. 86, 1, 2, 3, 4 days. 87, 2 days. 88, 1 day. 89, 1 day. 90, 1 day. All right, describe the shape and center. So the spread is from 82 to 90 beats per minute. The data clusters from 82 to 90 with a peak at 86. And in this case, the data is symmetrical, right? If 86 is the center of distribution, it's exactly the same on both sides. All right, so the nurse collected the data when the patient was resting. How might the dot plot and the measures change if the nurse collects the data when the patient is exercising? Well, the beats per minute is going to increase, right? So the heart rate might go up. So the mean, median, range, and IQR may also increase. Okay. I gotta go back to B. I forgot to mention the mean, median, range, and IQR. So the mean of this information, let's do this, 165. So I'm just combining these two at a time. So the mean of the heart rate is 86. The median, cross off from the ends until we find the middle value. Okay, so we're left with two 86s in the middle, so the median is 86. The range is 90 minus 82, so 8. All right. So 2, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so the lower quartile is 85. The upper quartile is 87. So the IQR is 2. Okay. All right, so again, the mean of B was 86, the median was 86, the range is 8, and the IQR is 2. The upper quartile was 87, the lower quartile was 85. So 87 take away 85 is 2. Okay, so that's it for data plots. In our next lesson, we'll finish up the 6th grade book by talking about histograms. So until then, I will see you soon.